Hi, I'm Chem's best friend. I make chemistry easy. I'm a graduate of MIT, and I have more than 17 years of experience teaching AP chemistry and chemistry classes. Please like and subscribe to my channel. And if you are interested in private tutoring lessons, the information is on the screen. Hello there. Are you ready to learn some more chemistry? Today, we're going to learn about stoichiometry. What is stoichiometry? It's the relationship between the relative quantities of substances taking part in a chemical reaction. That means you need your calculator. We will be crunching numbers. So grab your calculator and your periodic table, and let's learn about stoichiometry. Let's go to my screen. I think the best way to learn stoichiometry is to use a really great reaction. So the reaction we're going to learn is the reaction we're forming ammonia. It's called the Haber-Bosch process. It actually, when it was first developed in World War I, was really controversial. You should Google and learn the history behind it. It's quite interesting. So let's write our reaction. So we have hydrogen. We have our hydrogen gas reacting with nitrogen gas to make ammonia. And we have to balance this reaction. So we will have two nitrogens, and then we have 3 over here to have 6 hydrogens. Okay, a really fast review. What type of a reaction is this? 2 elements forming a compound. We have a synthesis reaction. And is this redox? Yes, it is. It's a redox reaction. Okay, so let's go to some math. So when we look at this reaction, what would you say to me if I ask you, please tell me what about this reaction? Tell me in words what you see. Chances are you would say, okay, I have 3 molecules of hydrogen react with 1 molecule of nitrogen to form 2 molecules of ammonia. Great. If I multiply everything by 10, will it still be balanced? Yes. If I multiply everything by 1,000, it will still be balanced. What if I multiply all the coefficients by chemist's favorite number, which happens to be 6.022 times 10 to the 23rd? Oh, a mole. So then this coefficient becomes mole-to-mole ratios. So I can say 3 moles. I have 3 moles of hydrogen reacting with 1, here's 1, yes, 1 mole of nitrogen molecules to produce 2 moles of ammonia. So these coefficients are my mole-to-mole ratios. And the reason it's better to work with moles is I cannot see 3 molecules of hydrogen reacting with 1 molecule of nitrogen. I will probably need to have something on a bigger scale, something that I can say if I have a factory making ammonia, if I put 100 grams of hydrogen into my reactant, how many grams of nitrogen I need. So this will become mole-to-mole ratios. Okay, so if 3 moles of hydrogen react with 1 mole of nitrogen to make 2 moles of ammonia, what if I have 6 moles of hydrogen? What if I have 6 moles of hydrogen? How many moles of nitrogen do I need? Well, you can quickly see that I doubled the hydrogen and it will be 2, but let's write this out nicely. So if I have 6 moles of hydrogen, I'm going to say, well, let's look here. There is 1 mole of nitrogen reacting per every 3 moles of hydrogen reacting. And that means if I do that, I do quickly the math, you can see 6 divided by 3, I will have 2 moles of nitrogen are needed to react with 6 moles. Okay, let's crank it up a notch. Instead of using 6 moles of hydrogen, what if I have, just make it, what if I made 26.35 moles of ammonia? That's how much I produced. So the question is, how many moles of hydrogen were used to produce 26.35 moles of ammonia? Well, we're going to use the same mole-to-mole ratios, same like we did in the previous example. So let's write this down. What do we have? We have 26.35 moles of ammonia, NH3. And now I'm going to look at my mole-to-mole ratio. So there is 3 moles of hydrogen I used up. 3 moles of hydrogen I used up for every 2 moles of ammonia produced. Now, look what I'm doing. I'm making sure my moles of ammonia, like remember, this is like over 1. My moles of ammonia is going to nicely cancel out, yes? So when I put this number in my calculator, I get that 39.53 moles of hydrogen were used to make 26.35 moles. So do you see how we can use the mole-to-mole ratios? Okay, let's go a little bit harder. We're going to still use the same reaction, and let's make it a little bit harder. What if I have 5 moles of hydrogen? I give you 5 moles of hydrogen. The question is, how many grams of nitrogen do I need? How many grams of nitrogen do I need to react with 5 moles of hydrogen? So maybe you see, wait a minute, if I'm going to have 5 moles of hydrogen, and if I figure out how many moles of nitrogen I use, that will help me. So 5 moles of hydrogen, well, what's going on? There's 1 mole of nitrogen used up per every 3 moles of hydrogen, yes? And now, is there any way I can change moles of nitrogen to grams? Yes, grab your periodic table. What's the molar mass of nitrogen? It's 14.0, and we have N2. So now we're going to have 28 grams of nitrogen for every 1 mole nitrogen. And nicely, my units, yes, moles of hydrogen, moles of nitrogen cancel out, and I'm left with grams of nitrogen. And if you plug this into a calculator, you will get 46.67 grams of nitrogen. So we're going to remember your sig figs. And because I only give you 1 sig fig, I need 1 sig fig answer. So this will become 50 grams of N2 can be produced if I use 5 moles of hydrogen. Okay, let's go a little bit harder. Let's make a new question. What if I have 15 grams? I'm going to put it a different color. What if I have 15 grams of hydrogen? How many grams of nitrogen was needed? Well, each question becomes a little bit harder, but here is how you're going to deal with this. You're going to look at the stoichiometry map. And this is the plan. That's how you're going to solve every stoichiometry question. And look what's going on here. We have our moles of substance A and moles of substance B. This is when we're going to use our mole-to-mole ratio from our balanced chemical equation, right? We were already doing this. But remember, you can have volume of substance A. You can change it to moles if it's gas at STP. Mass of substance A can be changed to moles through molar mass. And particles of substance A, you can change it to moles if using Avogadro's number. And the same thing is mirror image for substance B. So you're going to say, where am I on a map and where am I going? So let's look at our question. Our question is the red writing. If I have 15 grams of hydrogen, how many grams of nitrogen do I need to react with these 15 grams of hydrogen? Well, let's look at the map. We are with grams of hydrogen, that's substance A, and we're going to grams of nitrogen, that's my substance B. So I have to go from here, mass of A, use molar mass, go to moles of A, use my mole to mole ratio, goes to moles of B, and then go here to my mass of B. Okay, so let's do some calculations. So if we have 15 grams, this will be a little bit better, more sig figs, 15 grams of hydrogen. What's a molar mass? So 1 mole of hydrogen, let's change it to moles, is, well, which hydrogen is 1.01, so this will be 2.02 grams of hydrogen. And now I'm going to look at my balanced chemical reaction for my mole to mole ratio. There's 1 mole of nitrogen reacting per every 3 moles of hydrogen. And now I want to know the mass. So I have to use molar mass of nitrogen. So that is 28 grams of N2 for every mole of N2. Now please look to make sure your units cancel out. I have grams of hydrogen, and here's grams of hydrogen on the bottom. Moles of hydrogen cancel out. Moles of nitrogen cancel out. And I'm left with grams of nitrogen. And if you plug this into a calculator, you will get 69.3 grams of nitrogen is needed. Check your sig figs. I have 3 sig figs to start with. Every one of my molar masses is at least 3 sig figs or more. And then my mole to mole ratio is infinite. So I have 3 sig figs as my answer. Let's keep going. Let's change the question quickly. If I have 15 grams of hydrogen, how many grams of ammonia can I make? How many grams of ammonia? Let's keep going a little bit more. Well, let's start. If we have 15 grams of hydrogen, I need to change it to moles, right? Yes, where am I? Where am I on the map? I'm at mass A, and I have to go to mass B. Do you see it? So we're going to change it first to moles. So I have 1 mole of hydrogen is 2.02 grams of hydrogen. And now what's going on? Well, now I have 2 moles of ammonia. 2 moles of ammonia are made for every 3 moles of hydrogen used. And my molar mass of ammonia is, well, nitrogen is 14 and each hydrogen is 1. I'm going to say it's 17.0 grams of ammonia per every mole of ammonia. And when you plug this into a calculator and you use your 3 sig figs, it will be 84.2 grams of ammonia made if you use up 15 grams of hydrogen. So here is our map. And I think it's time to make things a little bit harder, because we just went this one from grams to moles to moles to grams. Let's go and do a little bit harder problems. Are you ready? I'm ready. So we're going to use the same reaction. It's great. What if I have 50 liters? 50 liters of nitrogen, or if I produce 50 liters of nitrogen, the question is, how many grams of hydrogen I needed to react with my 50 liters of nitrogen? Things are a little bit harder now. Okay, let's go to our map. And I am starting with volume of A. I'm starting with volume of nitrogen. So if I use 50 liters of nitrogen, how many grams of hydrogen? So here is my 50 liters. I need to go to moles, right? Moles of nitrogen. Then I'm going to go to moles of hydrogen. And then I can figure out mass of hydrogen right here. So that's my plan. So let's Let's do that. That seems like a great plan. Okay, so we're starting with 50 liters. 50 liters of nitrogen. Now this has to be gas and has to be at STP. You can use this. So what's the conversion factor? There's 1 mole of any gas per 22.4 liters. Okay, in my balanced chemical reaction, there is 3 moles of hydrogen react per every 1 mole of nitrogen reacts. And what's the molar mass of H2? Molar mass of H2 is 2.02 grams of hydrogen, H2 gas, for every mole of H2. And if you plug this into your calculator, you will realize that will be 13.5 grams of hydrogen is needed to react with 50 liters of nitrogen gas. All right. I think we're going to go a little bit harder. So same reaction, but here is the question. What if I have 7.89 times 10 to the 27th atoms of hydrogen? How many liters of ammonia gas can I make? Wow. Okay, let's go to our map. Let's figure out where we are. So we're going to start with particles, but our particles will be atoms. So we will have to go from atoms to molecules, right? We will have to go from molecules. Then we have to go to moles of our hydrogen. Then we have to go to moles of ammonia. And then we're going all the way here to volume of ammonia. Do you see it? So let's do that. Let's do that question. Okay. So we have 7.89 times 10 to the 27 atoms of hydrogen. Now, atoms are just single. Now we have to say, wait a minute, how many atoms? Hydrogen is H2. How many atoms? So 1 molecule of H2 is 2 atoms of hydrogen, yes? So now we have our particles, our molecules. So 1 mole of H2 is how many molecules? 6.022 times 10 to the 23rd molecules of H2. All right, now we're going to do our mole to mole ratio. So there is 2 moles of ammonia per every 3 moles of hydrogen. Okay, times, oh, we have to squeeze this in, times 22.4 liters of ammonia per every 1 mole of ammonia. And plug this into a calculator. What do we get? If you plug this into a calculator, we're going to have 97,828 liters. That's a lot, but we can only use 3 sig figs. Remember our 3 sig figs? So 3 sig figs is we will have 97,800 liters of ammonia can be produced with 7.89 times 10 to the 27th atoms of hydrogen. There you go. So this was a quick intro to stoichiometry. I think knowing the types of chemical reactions, I think we will need to meet again and practice a little bit more. But in the meantime, I hope this makes sense. I hope you learned something new, and see you next time.